Alright, in this next basic statics concepts of centroids, we're going to use the first moment of areas to find usually the location of the centroid of a particular area. This is a composite area where we have this upper arch curved thing that defines the upper boundary, and then we have multiple straight boundaries on the other edges. But we could actually look at this as one big curved piece and then cut off the triangle that's down here below. Right now we're given absolutely no numbers, so when we find the y-coordinate of the centroid of this area, you got to be thinking about that it's going to be symbolic. It's not going to be a number, right? So we have to very carefully kind of play this all out. Now notice we have this curve that is x equal to ky squared. That's kind of like a parabola. Right? Now if it was truly a parabola, it would go in the other kind of direction, right? It would be y equals kx squared, not this way. This looks like, in terms of x, a square root. Y equals the square root of x kind of thing. But if it is a parabola, just in a different space. Hey, if you rotated it this way, you'd recognize it as a parabola. That's going to be useful for us because we have lots of tabular values for parabolas. So why not? Let's use it. Right, so let's carefully lay out what this parabola shape looks like. And that big solid parabola there has a base, a total base of A, total height of B, and then there's our parabolic like curve. Right now when we go look this up, we may have to be pretty careful, because in this particular version of parabolic areas, notice this is in terms of y equals kx squared, not what we have, x equal ky squared. So again, this really is everything's flip-flopped. The roles of x and y are flip-flopped here. So that won't change the area. We got this big portion, not the lower subparabolic area, but this big area, and that's equal to 2/3 of the height times the base, and literally here 2/3 A times B, because that was the symbols that we've got here. Now notice it says find the y coordinate, so we're really going to go find y bar equals the sum of the little individual first moments of the areas divided by the total area. That's what we're executing here to go answer this question, right? So we need not only the area for this first one, but we're also going to need to figure out where its centroid is, as shown on this one. Here is the little value that we need, y bar 1. Now remember, again, what we're given is flip-flop from what we want, that the x and y roles are flip-flop. So we don't want y bar out of this particular one. We want x bar as shown here, because we really want something that looks, well, kind of like this, but flipped over to here. And notice, is that what we want? Oh man, this is kind of confusing, isn't it? Right? Wow. What do we really want? We want the height. We want going from the flat that is the central meridian. We want that distance over. Alright, so here is the flat that is the central meridian. That's the mirror line for this parabola, and we want the distance from that flat over. Oh, that's the x bar. That's what I mean by flip-flopping the x and y roles. We want the 3/8 of that dimension, and so that dimension is b, so our y bar here is 3/8 of b. Right? Now the triangle is similar. Oh yeah, I just recognized something that I didn't mark and would be an absolute deal buster on your work. What's the datum that we're using? Well, it's sort of presumed when you say find the y-coordinate that you're using the x-axis, but doggone it, we've got to clearly mark what the heck we're doing here. Right? There's more than one datum that you could possibly use, and once you choose one, it's got to be the same for all of them. You can't go flip-flopping around. Right, so there's our datum. Let's get our triangle in here, and let's be careful. The triangle is not just some lazy slapdash throw it out there triangle. It is one that has a height of b over 2 and a base of a over 2, such that then its area is 1/2 of its base of a over 2 times its height of b over 2, or ab over 8. Right? And of course its y bar from the datum is going to be, well, 1/3 of the height, which is going to be b over 2, so 1/3 of that is b over 6 for that height, right? And that's going to be technically a negative area, such that our total area is a2 minus a1. So that's 2/3 of AB minus AB over 8. And let's see, the common denominator here would be 24, so that would make that then AB times 16 over 24 minus 3 over 24, or that would be a total area of 13/24 of A times B. A times B being the rectangle that would go all the way around this thing. Okay, and we only have what, just slightly more than half of that area. Okay, and then we got to find our first moment with respect to the x-axis. That's the sum of all the little individual first moments, but we got to take due care of sign. So the first one would be 2/3 of AB times its moment arm of 3/8 of B minus then AB over 8 times its moment arm of B over 6. Right? And so that means the 3's go away, that's AB squared over 4 minus AB squared over 48. Ooh, let's check. 8 times 6. Yep, that's 48. Oh, well, what's the common denominator there? Well, that's going to be a 12 over 48 minus then 1 over 48. And so our first moment total will be 11 over 48 times AB squared. Right? And that gives us then what we need to go find our y bar, which is equal to qx over at, and so that equals then 11 over 48 AB squared divided by our total net area, which will then be that right there. And of course that's a little bit convenient, and so we get then 11/26 of B for that vertical centroid. Now let's see if that makes any sense. That's less than half of the height of this thing. Right? So less than half of the height. Right? So, well, we found out that if we just had only this parabolic area, we would have been at 3/8 of the height. So we already were less than. We took away area that was on the bottom. It should rise up. And sure enough, 3 divided by 8 is 0.375. 11 divided by 26 is 0.423. That is greater than the 3/8 B. So it has risen up. That's what it really should do. And that makes a lot of sense here for the centroid of that, or the vertical height of the centroid for that shaded area with respect to the x-axis.